So we connected and disconnected our players. Now it is time to add unique attributes such as a color. Because if we look at our game over here, we start refreshing, well, our players are white. It's really hard to determine what player is ours and what player belongs to someone else. So a great way to alleviate this problem is to give each of our players an individual color, and in this case, I'm just going to generate them on random. I don't want to get too much into how to pick a color. I think generating a random color is good enough for what we're trying to do here. So the very first step of this is going to be changing the color on the front end just so we get the white colors out of the picture. We want to render our players out as red to start just so we can see that color change taking effect. So where would we start doing this? Well, over within our public folder, we want to go inside of index.js because that is our front end file, and find out where we are assigning a color to our player. Now looking at this, you might say that is on line 14 because this is where we are creating a new player and it has a color of white. And you would be sort of right to assume that, or at least you'd have the right idea, but if we look very closely, we're not actually using this player const anywhere. If I were to scroll through our whole file, the only other place a player const exists is right here on line 42 and 43, and we're creating a new player const in this case that doesn't even reference the one that we created up here. And if that's the case, what is the point of having line 14? Well, we are going to use it later on within the series, but for now, it does not matter. This is confusing us. If it's confusing us, either comment it out or delete it completely. I'm a big deleter, so I'm going to delete it for now. We'll create it later. Now, where are we creating a color for our players? The only other place would be right here on line 21, where we are creating a new player with a color of white. Great. So how do we change the color? Well, let's change the string from white to red, save and refresh, and now we have red players within our game. Perfect. But what do we really want to do here? How do we randomize this color so that one player has a color of something like green, one has a color of blue? Well, rather than using pure static string colors like we are right now with white and red, we're going to use something like HSL. And this stands for hue, saturation, and lightness. It's basically just a way in which we can produce colors based on values. So for the first value, we want to select a hue. And we're going to select a hue on a color wheel range. A color wheel ranges from values of 0 degrees all the way to 360 degrees. We're essentially going across a full color wheel that consists of all the colors of the rainbow. And based on which degree we select is going to be what color we use for our end value. So I want to start off with a color of red. And where we're using a hue with a 360 degrees range, red is going to be 0. 120 is going to be, I believe it is green. And I think 240 is blue. But don't hold me to those. It's around those ranges for those colors. But we're going to use 0 to represent red. And then we want to add a comma and then specify our saturation. How intense should this color be? Should it be very, very intense or not intense at all, kind of faded to some degree? Well, in our case, we have a dark background, so I want all of our players to pop, as they would say, as much as possible so we can really see them, really see the contrast between the players and the background. And if that is the case, I want this to be the full intensity of our saturation value. And to do that, we can say this is going to be 100%. So for hue, our value ranges from 0 to 360. For saturation, we use 0 to 100%. And then same thing for lightness. We're going to use 0 to 100%. But what does lightness represent? Well, it's how much light we're adding to our specific color here. A value of 0 means not much light. It's going to be quite dark. And if we add a full value of 100%, that means we're pretty much almost getting towards the color of white. So we want something in between dark and light to show the full brightness. And in that case, we're going to say that our lightness value should be 50%. So if we save this, we did it all correctly, we added our commas and our percentage signs in place, refresh, we get the exact same result. But really, what is the difference between what we did right here with HSL and writing the string red? Well, by using HSL, we can manipulate the 0 value of hue to be different for each individual player. We're going to randomize this value completely to make sure that each player has a random value associated with it. But to start, let's go back to our checklist. We can check off change color on the front end. We definitely did that. But I want to focus on refactoring our player constructor to make sure your guys' code is as clean as we can possibly get it. So when we are creating our player right here, can you tell me what might be some things that are wrong with this, or things that could be improved, I would say? The first thing that I can think of is I might not know what some of these values mean. Yes, I can kind of deduct that x is going to be our x position. Same thing for y. But for 10, when I hit 10, well, I don't really remember what that 10 represents. And if that's the case, I have to go over into player.js and look at our constructor to really see what it is. And in this case, now I know it is radius. But it's kind of annoying to have to go back to a different file just to understand what a certain argument is. And if that is ever the case, well, you want to change these 4 arguments into 1. And we can do that by wrapping them within an object, like so. As long as we wrap all 4 of these within one singular object, now we only need to pass through 1 argument, but that 1 argument needs to contain 4 properties within it. And you'll see exactly how this fixes what I was mentioning earlier with not understanding what a certain argument is. So as long as we've done this within player.js and we saved, now we can go back to where we're actually creating this player within index.js. So rather than passing through 4 individual arguments, I'm going to pass through 1, which is just one large object. So I'll wrap those 4 arguments in the object. And now what I want to do is start giving these properties labels. So for our backend player.x, what is that really? Well, it's going to be an x property. And now all we have to do is set that x property, like so. It's as simple as that. Let's do the same thing for y. Our backend player y is going to be equal to a y property. And now for the 10, we know it's radius now, so we can put in radius, colon, and say that our radius for this player is going to be equal to 10. And finally, we have a color. Let's add color, colon. And now things look like this. This, in the future, is going to be much easier to read than trying to understand what this 10 was, what this other property was, or what any other properties we might add to these players are in the future. So now we have a label for each property. We know 10 represents radius, our x is going to represent x, y, color, and so forth. Much easier to read in my opinion, and another cool thing is, the location of each of these properties no longer matters. If we were to do the old syntax without the brackets right here, we would need to make sure that we put an x first, a y second, a radius third, and a color fourth. But when we use the object syntax like so, that is not the case. It does not matter where we put our radius, where we put our y, where we put our x. If I save this as is, things are just going to work exactly the same because now we're using this nice object syntax. So it's really better overall because we get these labels, the position does not matter, and it's going to basically help us think a lot more clearly in the future rather than worrying about what position our arguments go in and what they actually mean because we don't know in the first place. So that's why I wanted to walk you through that. We can check off Refactor Player Constructor. And one more thing regarding code cleanliness is I wanted to go through easier to understand variable and file names. As I was working on this project on my own, I noticed some things are kind of hard to understand and locate, mainly in regards to what our backend file is, what our frontend file is, and what our frontend players are, and what our backend players are. I was getting very confused between the 2 files, trying to understand which is our frontend, which is our backend, and so forth. So I think a quick file name changeup and some quick variable name changeups are going to do us a lot of good in this case. So the first thing that I would change is app.js right here. I'm going to rename this backend.js. It is much more understandable for me to know that this is our backend file. App.js, yes, it represents our backend app, but there was no indicator that was our backend. Now, there is an indicator. Much easier for me to understand, but if we change this file name right here, we need to make sure that whenever we are running that file within Warp or within Terminal, that we run it on backend.js instead of app.js. So just to show you that, let's go over to our terminal. Here it is for me. I'm going to exit out of our current process because I just changed the name of the file. And now I want to run nodemon, not on app.js, but rather backend.js. And things are going to function just as they did before. That's all we have to do in that case. But we get the benefit of knowing that this is our backend file. Now, what else would I change? Index.js, yes, this is typically what front-end files are called, at least the ones that you load on the first go. But it is not clear enough for me. I want this to be called not index.js, but rather frontend.js. Now it is much more clear to me that this is our front-end file. All of our canvas code goes here, while all of our backend code goes here. But if we were to change the name here, what do we need to do? We need to change the location in which we're referencing this file. So that is going to be within index.html. And if we look down below at the very bottom of the file, we are calling in index.js, but we changed the name to this, and it's going to be frontend.js instead. Let's give it a quick save, refresh, and we seem to be in good shape there. Now I also mentioned some variables as well. And really, when I was coding in frontend.js, I was getting confused in regards to what my backend players were and what my frontend players were. And it's really important to know the difference so that you're manipulating the right object at the right time, especially as we start to add in things like player movement. So what I'm going to do is not call our main players object on the front end players, but rather front end players. And I'm actually going to make sure that for front end, I use a capital E. It's kind of up to interpretation whether or not you want to capitalize the E. But I think since this is its own individual word, it makes sense to capitalize that. And that is what I'm going to call that const. So now we need to find every location in which we used players and replace it with front-end players instead. So let's go through this real quick. Right here, we're referencing backend players. That is perfect. We do not need to change that unless we want to follow the syntax in which I reference up here of using a capitalized E, which I suppose in this case I will, just to be as consistent as possible. So any place I see a backend player, I'm going to replace that with a capitalized E. And I think that takes care of everything. Sorry to make you guys do this, but I think this is going to be very understandable for us in the future. Now, every location in which we had players, we need to change that to the front-end players object in which we just renamed. So we can already see right here within this if statement, we're referencing players. And when I first looked at that, that was confusing to me. I didn't know if this referenced the backend players or the front-end players. And that is exactly why we're changing this. We're going to make this as clear as possible so that we can understand our code better in the future. So these two locations right here, I'm going to replace players with front-end players. Now I know if front-end players does not exist, if a front-end player does not exist per se, then we're going to assign that front-end player a new player object. Much, much, much more clear to me. And then finally, this relates to deleting players. We want to loop through our front-end players, not our backend, and make sure that we delete the player from the front end. Much more clear once again. I'll delete this console log because I don't believe we're using it, but we need to keep scrolling. We're no longer looping through just our players, but rather our front-end players. And I want to rename these two player instances, front-end player, to be as explicit as possible. And I think that takes care of everything. If you need code to compare it to, or if you need this exact code, remember, all this code is going to be split up into different commits within a Git repo based on the lesson you're currently watching. So very handy in case you need to go back in time, trying to make sure that I keep you guys as much in the loop as possible. So going over here on refresh, you can see I have a quick bug. No problem, happens all the time as a developer. So I want to right click, go to inspect element to open up our console. And I have this way zoomed in so you guys can see everything clearly. So I have to zoom out a little bit. Looks like I have the bug backend players not defined somewhere. Looks like on line 22 within frontend.js. So let's go there, line 22, and backend player is not defined. So remember, I'm using the capitalized E for our convention. But when I created one singular backend player right here, I did not use that capitalized E. We want to make sure we change that. Save, refresh, and we're back in business. Perfect. We are looking great. So I think that's all I want to do now is make sure that we have a front-end file, a back-end file, named correctly at least, and that we're referencing front-end players on the front end correctly and back-end players on the back end. Did we do the back end? Sorry, let me check. Backend.js. Let's do the same thing for the back end because it looks like we didn't. Sorry to try to end that early on you guys, but for line 18, we're in the backend file. Yes, we have a players object, but it's much more apparent if this is going to be a back and players object instead. So every place we referenced players prior, we want to change that. It's going to be right here, right here, right here, right here, and then right here with console log. I'm selecting all these by holding down Command within Sublime Text, and then double clicking. That's how I got all of them at once. And if you select everything at once, you can just hit delete. Deletes all of them in the same locations. We have multiple cursors. Then we can hit Command V. Paste it in back in players, which we changed up here, in all those locations. And that should be it. Let's save, refresh, make sure that everything works. It looks like we are good to go. So back over here, we can officially check off easier to understand variable and file names. It's going to make our life so much easier in the future. But let's get back to the meat of this tutorial, which is generating random colors on the back end. So we can create colors on the front end, and we are currently doing that within frontend.js right here when we set our color equal to HSL 0150. But can you tell me what the problem with generating this on the front end is? Well, if a player can determine their color on the front end, they can basically manipulate this code to be whatever color they want. We want all these to be randomly generated, but to make sure that they always have a saturation of 100 and a lightness of 50. That way, they're never going to blend into the background. Can you imagine if a player decreased the lightness value so that they are very dark, and they just looked like a black square, or not a black square, but a black circle on this black background? We would not be able to see them at all, but they would still be able to function and shoot all of the other players. That is basically cheating for the game. We should always be able to see a player, and we don't want them to be able to blend into the background. So instead of generating this on the front end, where a player could cheat and manipulate this color, we want it to be done on the back end, so the player has no say of where it's done and what color they are. So yes, we are going to be passing through a color right here, but it's going to be dependent on the backend players we pass through the backend. So we're going to generate this on backend.js, and lucky for us, we changed that file name, so it's much easier to go to. So within backend.js, we want to add in a new property for all of our backend players. So right here, where we are adding in the current X and Y properties, all we need to do is add in a comma and specify we want a color now. What is color going to be equal to? Well, we kind of wrote this out over in frontend.js. It's going to be equal to HSL with all these values. Let's copy that string and paste it in as our color value for our backend players. So now we're saying every player by default is always going to be a red color. They cannot change it because it's passed through the backend. But we want every color to be randomized. And to randomize this color, we want to change this value of 0 to something that's programmatically generated. And to do that, we can use backticks to create this string. So right now we're using single quotations. I'm going to replace both of these with backticks. So one backtick there, one backtick there. This works exactly the same, but using the backticks, we can use this new syntax. It looks like this: $, opening and closing curly brackets. And this is going to allow us to push in a programmatic variable. We're going to run some code right here that generates a random number. And the code I want to run is 360, the full range of our color wheel, times math.random. So math.random gives us any value 0 to 1. If we multiply that by 360, well, we're basically getting any value 0 to 360. Exactly what we want right here, but when we use the string interpolation syntax, it's going to allow us to get a random value for each player that runs this code right here. And this code is ran every time a player connects, so we're always going to get a different value for HSL. So we definitely want to save backend.js with this new code, but in frontend.js, we're still using the same red color. We want that new backend generated color instead. So we know whenever we call update players, yes, we are calling the following function. We are referencing one singular backend player that we're looping over. These backend players, now that we saved a color within backend.js, these backend players have a color property associated with them. So rather than reference a static string like we are right here for color, we're going to reference backend player dot color instead. And now we should get a random color every time we refresh our page and a new player joins the game. So let's refresh. And we seem to be in great shape with generating those random colors. Yes, some of the colors could technically be the same, but I think to give you the general idea of how this works and how to get new colors on the screen is okay. I want the game to be kind of chaotic anyways. I don't really care if 2 of them are green. Should be fine for me as long as the colors are generated on the back end and a user isn't cheating to get some sort of black color while they scroll around and kill everyone. Make sense? Yeah. So I think that's going to be good for generating the backend color. But while we're on the topic of kind of refactoring and making sure that things are as easy to use as possible, I think it kind of makes sense to enhance our canvas resolution. It's more of like a side thing, but I still think it's important to teach you guys. If we look closely with our new colors, especially on this little pink guy right here, you're going to notice it's kind of jagged and it's not very clear because I'm trying to render out a standard size canvas even though I'm using a MacBook Retina display. Technically, the resolution on the canvas should be 2 times, and it would be nice if it did that automatically, but unfortunate reality is it does not. So we have to code that functionality ourselves to make sure that our players are as clear looking as possible. So here is how we're going to do it. We're going to go inside of frontend.js, and we're going to use a property called device pixel ratio. I'm going to create a const called device pixel ratio, and it's going to be equal to window.device pixel ratio. But if a browser does not load this property, if the property is not available on a particular browser, then I want to load a backup value. And we can do that by adding in a double pipe right here. It's basically the OR operator that says the default value for this should be 1. So since I use a MacBook display, my device pixel ratio is going to be 2 times. So this will return 2. But if you're not using a Retina display and you just have kind of like the basic default values, this is going to return 1. But if we don't have anything, we're going to return the value of 1 because that's kind of like the base standard mode of our game. This is all we need to start. So what I want to do is multiply our canvas width and height by whatever our device pixel ratio is, so that if you're using a MacBook Retina display, we're going to make sure our canvas width and height is 2 times the size of what it originally is. Let's do that right now. I'll copy device pixel ratio and multiply inner width and inner height exactly by that. So if we save and refresh, and I start scrolling, you're going to notice our canvas width and height is 2 times the size. I can scroll to the right, I can scroll down because I multiplied that by 2. But we don't want it that big, actually. We just want it taking up the full width and height of the screen. Why are we doing this in the first place? Well, if we multiply this by the device pixel ratio, we know it's 2 times as big. We can select our canvas within index.html using CSS and make sure that our canvas width and height are both set equal to 100%. So yes, the resolution is going to be twice as big, but we're going to compact it to the width and height associated with the browser. And if we do this, we're going to get players that look way more clear than they did before. Let's save, refresh, and it looks like over here, it's only being read within my other browser, Min. Not sure what's going on with Firefox, just had a hard refresh. It was reading the cache version. So right now, yes, these are definitely more clear, or so it seems. But one obvious issue is, well, they are way, way, way smaller than before. And this might be okay. This might be the size in which you want your game to run. But in my case, no, I want these to be the same size that they were prior. So if I want to make sure that our players are rendered at the same size they were prior, I'm going to use this property right here, window.device pixel ratio, go over to player.js, and make sure that we multiply our player's radius by this value right here. So really, it's either going to be 1 or 2, but it's going to render out players as they should be seen on the screen based on what your display resolution is. So if you have a lower display, they should be the correct size, and if you have a high-res display, they should be the correct size on your screen as well. We're going to multiply the radius by that, refresh in both locations. I'll do a hard refresh on both. Try to with my Min browser over here, which always gives me issues. And there we go. So I might be zoomed in a little on one of these, which explains the discrepancy of actual sizes. But if I were to zoom in a bit more on Firefox using the browser zoom, you can see that these are way, way, way more clear than before. There's really no jaggedness associated with them at all because we're using the device pixel ratio. So that's exactly what I wanted to do, and I think that is great for making our game look as clear as possible, while maintaining the clarity as much as we can within browsers that might have a lower resolution. So I think that is a great lesson for teaching you guys how to add random colors, how to make them look good on the browser, while keeping your code quality in check, because it's always very important that we can reference things as needed, using the correct file names, correct variable names, and the best practices like using the object syntax that we see right here for player. So with that, we can finally check off enhance canvas resolution, And that is going to allow us to check off add unique attributes, specifically a color.